यस, लास्ट डे हमने कहाँ तक डिस्कस किया था? ट्रांसफर इफेक्ट
सर
का।
लास्ट ऑर्गेन डायग्राम का थोड़ा हुआ था। ऑर्गेन डायग्राम का
ऑर्गेनो डायग्राम, यस ना?
हाँ, तनाबे सुगानो डायग्राम से भी क्वेश्चन पूछे थे।
यस, हो गया, कंप्लीट है। नेक्स्ट हम चलते हैं मैग्नेटिक। यस, टुडे टॉपिक इज मैग्नेटिक। फर्स्ट ऑफ ऑल, व्हाट इज मैग्नेटिक? व्हाट द डिफरेंस बिटवीन पैरामैग्नेटिक, डाईमैग्नेटिक, फेरोमैग्नेटिक, फेरीमैग्नेटिक, एंटी फेरोमैग्नेटिक? एक्सप्लेन वन बाय वन।
ओके, so magnetism is a property which possesses by a coordination complex or any type of compounds, shows the actual dipole moment or the direction of the spin angular momentum of a complex. So magnetism can be classified into various types. One is paramagnetic, second is diamagnetic, and there are some another classification which is called ferrimagnetism and ferromagnetism. So in case of paramagnetic complex or paramagnetism, when a complex contains paramagnetism, so to check that, we have to check the electronic configuration of the complex. If a complex possesses a single electron or unpaired electron in its free shell or in its uh, valence shell, then because of the possession of unpaired electron, it will show a type of magnetism which is called paramagnetism. This type of compounds are attracted to magnets. So this is why it is called as paramagnetism or paramagnetic material. And in case of diamagnetic material, there are no unpaired electron present. If a compound having no unpaired electron in its valence shell or in its electronic configuration, then it will show diamagnetism. So one paramagnetic material will be I'm now giving an example. Let's see. This will be a paramagnetic material. And an example for diamagnetic material will be in this case, cobalt contains D6 electronic configuration, and in this case, titanium consists D2 electronic configuration. This is a low spin complex, as we know that water acting as ligand with central metal atom cobalt, it acts as a strong field ligand. But here in case of titanium, it will act as weak field ligand and it will be a high spin complex. So this is why there will be unpaired electron in this case, which will occur, which will show the paramagnetic behavior of this compound. And in this case, there will be no unpaired electron. Every electron in this case are paired. So this is why this will be called as a diamagnetic complex or diamagnetic material. Or there are some compounds which show ferrimagnetism and ferromagnetism. So in case of ferrimagnetism, the magnetic moment of those compounds are looking like this. This type of magnetic moment showing compounds are called as perimagnetism. And when the magnetic moment is looking like this, then it will be called as a ferromagnetic compound. So in this case, Fe2O3 will be an example for ferromagnetic compound.
Yes, good. Paramagnetic, dimagnetic, ferrimagnetic, yes, and antiferro.
Oh yes sir, yeah, antiferromagnetic भी है. Antiferromagnetic material's magnetic moment will be looking like this. So a compound which show antiferromagnetic behavior, I currently can't recall the exact compound which show antiferromagnetic behavior, but the magnetic moment of this type of compound is like looking like this. But in case of the transition metal or heavier metal like lanthanide metal, the process of determining the magnetic moment of a coordination complex is quite different. There are 4 equations which shows the value of magnetic moment in coordination complex. So we have to know which equation will be used. One equation is mu spin equals to root over 4s into s plus 1, or mu spin equals to root over n into n plus 2. One equation is mu s plus l root over 4s into s plus 1 into n into n plus 1. One equation is looking like this: mu equals to g into root over j into j plus 1. And another equation of determining magnetic moment is mu effective equals to mu spin into 1 minus alpha lambda by delta. So this is the 4 equation which can be used to determine the absolute or actual value of magnetic moment in a coordination complex. But now we have to see the cases where a particular equation is used. So in this case, we know, or we take an atom in which electrons are rotating, and while rotating, the electrons has 2 type of motion. One is spin motion and another is orbital motion. So when these 2 motion is present in a molecule, then we will use this equation. When spin orbital coupling occurs, we use this equation mu s plus l equals to root over 4s into s plus 1 plus l into l plus 1. And in case when spin only magnetic moment is present, then we will use mu equals to root over n into n plus 2. But you can say when spin orbit coupling occurs at the case when T2G orbit is unsymmetrically filled, then spin orbit coupling occurs. And the third equation where mu equals to g into root over j into j plus 1 is used in, this is used for heavier metals like lanthanide metal or actinide metal. And the last equation, mu effective equals to mu spin into 1 minus alpha lambda by delta. This equation is used in case of 4D and 5D metals, because in this case orbital spin orbit coupling doesn't occur because of the 4D 5D metals are mostly showing the low spin complexes. So in that case only spin only magnetic moment is present, and there are some deviation in this case. So to reduce the deviation, the equation is formed like this to get the accurate value of the magnetic moment of 4D and 5D metals. In this case, alpha is a constant for each energy term, and the lambda is spin orbit coupling. So this is the way we can predict or we can value the actual data of magnetic moment in coordination complex.
Yes, good. What the difference between paramagnetic susceptibility and dimagnetic susceptibility?
In case of paramagnetic susceptibility, we see a compound when a compound possesses paramagnetic behavior, which means the compound possesses a unpaired electron, or unpaired electron is present in the case of any material or complex, then it will show the susceptible behavior of in magnetism, which is called the paramagnetic susceptibility. But in case of diamagnetic susceptibility, the materials are used in this case are diamagnetic and which doesn't possess any unpaired electron, and the susceptibility of in magnetism will be called then as the diamagnetic susceptibility.
Yes. And molar susceptibility? What is molar susceptibility? Molar magnetic susceptibilities.
मोलर ससेप्टिबिलिटी तो पता नहीं, क्या होता है सर वो?
फॉर्मूला कुछ पता है? XM इक्वल टू X इंटू M इक्वल टू KD इंटू M.
अच्छा, ये फॉर्मूला मुझे पता नहीं था, मुझे सिर्फ वो xm वेरीज एज 1/t ये
X इक्वल टू K अपॉन D. गामा इक्वल टू कर सकते हो. गामा इक्वल टू तो एक रोटेटेड है, मानना है आप.
k अपॉन d.
यस, स्मॉल k अपॉन D.
ये मोलर मोलर
इसमें K है, मैग्नेटिक ससेप्टिबिलिटी है.
अच्छा,
एक मैग्नेटिक परमेबिलिटी और मैग्नेटिक ससेप्टिबिलिटी, इसमें क्या डिफरेंस है? जो B अपॉन H होता है और I/H डिस्कस करते हैं क्या मतलब है इसका।
सर ये तो पता नहीं है। ये वाला पार्ट तो वैसे
इनिशियल ही है ना,
पता।
पार्ट इनिशियल का, ये बेसिक पार्ट है।
जो ससेप्टिबिलिटी वाला पार्ट इतना मैंने पढ़ा नहीं था, वो एक्चुअली वो जो विंस लॉ होता है वही विंस लॉ ही सिर्फ पता है, और उतना देखा नहीं है। ठीक है, देख लूंगा मैं।
ठीक है, आप देख लेना, कोई दिक्कत नहीं है, देख लेना, बस क्वेश्चन बेसिक है। ठीक है,
हाँ, कि मोलर
नेक्स्ट हम डिस्कस
ससेप्टिबिलिटी
करते
आपने
हैं,
बोला।
यस, क्यूरी लॉ एंड नील टेम्परेचर, क्या डिफरेंसेस है क्यूरी लॉ और नील टेम्परेचर।
क्यूरी लॉ तो सर वही है ना जो एक्सएम वेरिसेस 1/t होता है। मैग्नेटिक ससेप्टिबिलिटी टेम्परेचर से इनवर्सली प्रोपोर्शनल होता है। जब टेम्परेचर इंक्रीज होता है तब मैग्नेटिक ससेप्टिबिलिटी कम हो जाता है।
यस, एक्सप्लेन कीजिए नील टेम्परेचर और क्यूरी टेम्परेचर को, फॉर्मूला क्या है, क्यूरी लॉ क्या है।
सर Curie law is basically that the magnetic susceptibility of a material is inversely proportional to the temperature. So if temperature increases, Im decreases. The equation is Na mu square by 3 kT, which is basically C. We take this part as constant, as C, and then it will be looking like this. और क्यूरी पॉइंट अगर आप पूछे तो क्यूरी पॉइंट होता है टेम्परेचर अबव व्हिच फेरोमैग्नेटिक मटेरियल टर्न्स इनटू पैरामैग्नेटिक मटेरियल, दैट इज कॉल्ड क्यूरी पॉइंट, वेयर ferromagnetic material turns into paramagnetic, that is called Curie point. Temperature above when ferromagnetic compound turns into paramagnetic compounds.
यस, ग्राफ बना सकते हैं, ग्राफ मैग्नेटिक ससेप्टिबिलिटी और टेम्परेचर के
हाँ,
वर्सेस क्यूरी एंड नील टेम्परेचर, ग्राफ मैग्नेटिक ससेप्टिबिलिटी और टेम्परेचर के लिए ग्राफ बनाइए आप, डाई मैग्नेटिक, एंटी फेरोमैग्नेटिक, पैरामैग्नेटिक, फेरोमैग्नेटिक, क्यूरी एंड नील
okay.
टेम्परेचर रेस्पेक्टिवली।
So in case magnetic susceptibility versus temperature. this is for antiferromagnetic compound. This graph is for paramagnetic compound, and this graph is for ferromagnetic compound. This is the graph of magnetic susceptibility versus temperature in various materials. And this is the Curie point, and this is the Neal point. What is Neal point? Neal point is the temperature above which antiferromagnetic compound turns into paramagnetic compounds.
Yes, good. Next, move on. What is magnetic moment? How to determine magnetic moment of S block, P block, D block, F block elements? Explain one by one with formula.
So a compound showing magnetic behavior can be determined through the theory of magnetic moment, and we can predict the magnetic moment of a particular compound by a magnitude using some equation. So if, let's say, take a atom in which electrons is revolving around, so the electron, when it is revolving, then it will have two types of motion. One is spin motion and another is orbit motion. So these two motion of electrons, these two motion of electron generate two magnetic field which create magnetic moment. So this is why magnetic moment is present in a molecule. That an electron revolving around the nucleus, it has spin motion and orbit motion, and these two motion of electron generate two magnetic field which create the magnetic moment. So in this case, when P block, S block or normal D block element, to count the to determine the value of magnetic moment in case of SP block, D block element, we use spin only magnetic moment, because in this magnetic moment part there is two part. One is spin and one part is orbit. So there is a spin contribution and one is orbital contribution. So in case of SP block and normal D block element, there is no orbital contribution. So if there is no orbital contribution, then we can use this equation. Mu spin equals to root over 4s into s plus 1, and another equation which is very common, which is n into n plus 2, where n is the number of unpaired electrons. And the s here at the above equation, s is the spin quantum number or spin multiplicity. This is for SP block element. But when in case of orbital contribution occurs in coordination complex which have unsymmetrical T2 or unsymmetrical T2G orbital, T2G or T2 orbital, it will show orbital contribution in magnetic moment. So then the equation will be mu s plus L root over 4s into s plus 1 into L plus 1. So for the orbital contribution, this L into L plus 1 term is added in this case, and we can write it as the previous like this. So this is the two types where only spin only magnetic moment present, and in here spin orbit coupling occurs. So this is why we have to count both contribution in this case. So then we will use this equation in case of spin orbit coupling. But now, sir, मैं इसे रब कर दूं?
Yes, good.
So now we will see the equation to determine the magnetic moment in case of the heavier metals like lanthanide metal or F block metal. So we use the equation for determining the magnetic moment of lanthanide metal is mu equals to G into root over J into J plus 1. Here G is a constant. It is called Russell-Sanders constant. So we have an equation of G here. How to determine the G in case of a block element. By this equation, we can predict the value of G, and the value of J is L minus S and L plus S for less than half field, and this is more than half field. So you can predict the value of J and G by these equations. This is for F block elements. So in case if we have to know how the magnetic moment determination occurs in case of 4D and 5D elements. So in this case, there are some deviation in magnetic moment. We can experimentally, when we get the value experimentally, you can see some deviation in case of this type of 4D 5D element complex. So then we will use the equation mu effective equals to mu spin into 1 minus alpha lambda by delta. By this equation, we predict the value of magnetic moment in case of 4D 5D element. Also, some copper 2 plus complex also show some deviation at the spin only value. Then we also use this type of equation to determine the actual magnetic moment value for coordination complex. This is the all total theory how to determine or how to calculate the magnetic moment for every type of compounds and complex. Sir, is it correct?
Yes. Yeah, transition element is due to spin only. Yes, no. Lengthened in a spin plus orbital motion. Yes, no?
लेंथेनाइट पे ज्यादा वो स्पिन स्पिन वाला ही होता है, स्पिन ओनली वाला ही होता है।
Spin plus orbital motion. Mu is equal to G root J J plus 1. Yes, no?
हाँ हाँ,
Spin plus orbital motion.
J+1।
Yes. Yes. How many types of magnetic moment change in magnetism and coordination chemistry? How many types? Process, method.
How many method?
Yes, process. Like unpaired electron. Unpaired electron से magnetic moment change होता है. ऐसे कैसे कितने मेथड है? How many types?
ओ अच्छा, तो सर मैग्नेटिक मोमेंट चेंज होने का मेन कॉज और मेन कारण होगा जब द नंबर ऑफ इलेक्ट्रॉन्स अनपेयर्ड इलेक्ट्रॉन्स विल बी चेंज। इन दैट केस द मैग्नेटिक मोमेंट विल डिफर फ्रॉम one to another, and also in case where we can see that if spin orbit coupling occurs, then the value of magnetic moment is different, and when only spin only magnetic moment is occurs, so no orbital contribution, then the value of spin only moment magnetic moment and spin orbit coupling magnetic moment will be different. So in those case, there will be some change in magnetic moment value, and in case of heavier atoms, we use this equation by which we calculate and add all the spin orbit contribution and spin orbit coupling within the f-block elements, and the last equation where we can see that if some deviation occurs in the magnetic moment value, then we have predicted this equation which follows the accurate magnetic moment in case of coordination compound.
Yes, magnetic moment, orbital contributions, free ions, LS coupling, first perturbation theory, spin crossover. Yes, no?
हाँ हाँ हाँ, ये
Ground state term change is orbital motion, orbital contribution. Yes, no? So 6 type of
yes
method.
yes
Yes, no? Change in magnetic
yes sir.
moment. Yes, good. Next, move on. Next topic is last topic is reaction mechanism. Yes, stability of complex and reaction mechanism. Yes, what the difference between thermodynamically stability, kinetically stability? What the uses of these one in any reaction in reaction mechanism? Explain.
So if a compound is stable with respect to thermodynamical aspect, then the compound will be called as thermodynamically stable, and the kinetically stable product is also another type where the changing parameter or the stability parameter of a compound is different. So in case of thermodynamically stable compound, we are talking more about the temperature of that compound. By difference of the temperature, the compound will be stable. Those type of compounds are called as thermodynamically stable compound, but the kinetically stable compound is those type of compounds which prefers by the best kinetic route, and which emerges very fast. So those type of compound is called as kinetically stable compound, where it is produced by the best kinetic pathway and produces so fast that this that those pathway where the product is formed is become the main pathway. So those type of compounds are called as thermodynamically stable compound, kinetically stable compound, and the thermodynamically stable compound are the actual stable compound which are not reactive like kinetically stable compound.
Yes. Any example? Kinetically, example of reaction.
एनी एग्जाम्पल सर अभी याद नहीं आ रहा है, लेकिन अभी तो सर अभी याद नहीं आ रहा है, मैं देख लूंगा.
Yes, no problem. Next, move on. Which factor affecting in stability of complex kinetically, kinetically and thermodynamically? Which factor affecting? How many factor affecting?
The stability of a complex is depend on the value or the magnitude of CFSE, and also the stability is dependent on the lability of the complex, which can be predicted by the lattice energy graph. So if we plot a graph of lattice energy of coordination 3D transition metal against atomic number, then we can see the atomic number increase with atomic number. This is how that lattice energy changes. So in this case, we can see that the D0, D5 and D10, this metal are most stable in this case, and the lattice energy for D3 and D8 are quite high. So this shows the reactivity of the compound with the conformation or the electronic configuration with D3 and D8. By presenting the conformation D3 and D8, we will show the reactivity or the stability of a compound. So now the compound which possess the D0, D5 and D10 structure, we will see the stability order of those complex. So the CFSE value of Ni2 plus is greater than V2 plus.
Yes. Yes. What is Irwin-Williams series? What the main application of Irwin-Williams series in magnetic